This lesson we'll learn about normal distribution, but first we'll have to understand what a continuous random variable is. Now, we know that discrete variables are variables which can take particular values only, and there are no in-between values. However, a continuous random variable is a variable which has infinite number of possible values. So for example, if we take the mass of an apple, it can be 100.1 gram, it can be 100.11 gram, 100.112 grams, and there can be infinite possible values for a mass of an apple. So the probability that the mass of an apple takes any one value is zero, as there are infinite number of possibilities for the mass. And we can take example of height of people as well. They can take infinite number of possible values. They can be 155.1 centimeter, 155.112 centimeter, and so on. So the probability distribution of a continuous function represents the range of its values and the probabilities for intervals within that range. So when a random variable x is discrete, it is represented as probability of x is equals to r, as it can take any particular value. However, when a random variable is continuous, we represent it as probability of x is less than equals to a particular value and greater than equals to another value. Now, if we draw a graph of a variable which is continuous, and we make a histogram with the probability density on the y-axis, it will be such that the mean will be centralized, and as we move away from the mean, the probabilities of each of those values will start to decrease. We can just take an example of for the height of people. Let's say the average height of people in a certain area is, let's say, 170 centimeters. So most of the people will have the height which is near to this value. And as we go away from the value, higher or lower, the probability of that will start to decrease. So a continuous function is represented as this bell-shaped curve where the mean is centralized. So this is the mean, and these values represent standard deviations away from the mean. So this is mu plus 1 standard deviation. This will represent mu plus 2 standard deviation, and this will represent mu plus 3 standard deviation. And similarly for values which are less, this will be mu minus standard 1 standard deviation. This will be mu minus 2 standard deviations. And this will be represented as mu minus 3 standard deviation. The total probability, we know that it will always be equals to 1. So we can see that a value which is 3 standard deviations away from the mean, the probability of that occurring will be very less. Now, as there are infinite possibilities, most of the problems that we have can be solved by transforming this graph, which we call the normal distribution graph. So this is called the normal distribution graph. And we represent this normal distribution graph as, so let's say if a variable x is normally distributed, it will have mu and variance. So this is mu is called the mean, and this is called the variance. Now, as there are infinite possibilities, we transform this into the standard normal variable where the mean is centralized and taken as 0. So let's say this value is 0, and this 1, 2, and 3, these are standard deviations away from the mean. And these values are basically called the z values. So this will be -1, this will be -2, and this will be -3. Now, the total area of this graph, and we say that this graph is the graph of y is equals to phi of z. And if we draw any vertical line on this graph, so let's say if we draw a line over here and this value is z, so it divides it into two parts, towards the left and towards the right. So we can write it as probability of z is less than equals to z, which will be towards the left, and the other half will be probability of Z for greater than this value of Z, which will be towards the right. And this probability of this value will be denoted by phi of Z. Now, the probabilities of these different values of phi of Z are compiled in the normal distribution table, which is provided in our formula sheets as well or in our books. And this is what the what the normal distribution table is like. So let's say from our table we had we had a Z value which was, let's say we had to find Z is less than equals to 1.1. Now to find this probability, we'll go to the table, and on the left hand side and over here these are the Z values, and in the middle we have the probabilities for each of those Z values. So if the Z value is 1.1, we'll come to 1.1 and see what the probability is, and this probability over here is 0.8643. So this probability will be 0.8643. And if we had to find the probability of Z is greater than 1.1, then we can just simply subtract 1 from 0.8642, and this will give us the probability towards the right hand side. And as this graph is symmetrical, so it will basically, this will work out for negative values as well. We do not have negative values in the table, but let's say we had to find the probability of Z is greater than minus 1.1. So we know that minus 1.1 would be somewhere over here. So let's draw it over here. And we had to find the probability of greater than minus 1.1, and we also had to find the probability of Z is less than minus 1.1. Now, if we go to the table, we know that the probability for Z value 1.1 is 0.8643. Now we can see that greater than means towards the right, which means that we are talking about this area. For Z is greater than minus 1.1, we have to find this total area over here. Now, as the graph is symmetrical, we know that, and this is the center point. So this half, the right hand side is 0.5, and the left hand side will also be 0.5, the total probability or the area. So we know that if this is minus 1.1, this yellow shaded area will have a probability which is greater than 0.5. So in this case, we can just write it as 0.8642. And for less than minus 1.1, this will become minus 1 minus 0.8642. So we can have any value of Z, and we can find the probability from the table. Let's just take one more example. Let's say if we had to find the probability of Z is greater than 2.45. Now, if the Z value is 2.45, we'll come over here in the table. So this is 2.4. And then we'll go to 5 over here. So this is 5. So we'll come down over here, and this is 2.4, and this will be 2.45, which is 0.9929. Now this 0.9929 probability is basically, so the Z value is 2.45, it will be somewhere over here. So let's say this is 2.45. Now what we can observe is that this towards the left hand side, this probability will be greater than 0.5. And from the table, the probability that we got was, so the probability was 9929. So this probability would be 0.9929. In the question, we had to find the probability which is greater than 2.45, which means we had to find this probability. So we can just simply subtract 0.9929 from 1, and this will give us the probability for Z greater than 2.45.